To solve an exponential equation that requires the use of logarithms, we are going to need to learn a new formula called the change of base formula. Now, the whole purpose of this change of base formula is so that we can solve exponential equations here that do not have a common base. For example, 6 and 40, there's no way to rewrite those so that they have a common base. So when we change them into a logarithm, we can use the change of base formula to find the decimal that equals x. And the change of base formula looks a little like this. You may want to pause the video to write that down. But we have log base b of a equals log of a over log of b. Notice how the base goes to the bottom of the fraction. I like to call that the basement, goes to the basement of the fraction. And the a, I consider the attic. It goes to the attic of the fraction. And both numbers are of numbers. So the base changes to an of number and a stays as an of number. And we rewrite these with a common base or a base of 10 so that I can use my calculator to actually calculate out what the number is. It can be used to make it into any base you want. We just use a base of 10 because that's the button that we have on our calculator. I know that I'm using a base of 10 because remember, when the base is invisible, we always know that it is base of 10. So let's take that knowledge and work out our problems here. We want to rewrite log base 3 of 7 using common logarithms or using our change of base formula. So I'll have two logs, one on top, one on the bottom, and the attic number is 7, so log of 7 will be on top, and the basement number is 3, so 3 will be on the bottom. And now we can just type it into our calculator with the log button. So log, it's right next to the 7 of 7. Make sure that you close your parentheses. If you don't close your parentheses, you're not telling it to stop making the of number. Closing the parentheses tells the calculator that you are done inputting the of number. Divided by log of 3. And then hit enter, we get our nice long decimal, and we're going to round it to 4 decimal places. So 7712. Let's do it again. Log base 4 of 23. I don't know that off the top of my head, so I'm going to have two logs, one on top, one on bottom. And I'll have my attic number, and I'll have my basement number. So I can type into my calculator, log of 23, close your parentheses, divided by log of 7, close parentheses. And we get 1.6113. For number 3, a log on top and a log on bottom. My attic number is 13, and my basement number is 9. Time to type into my calculator, log of 13, close your parentheses, over log of 9, close your parentheses. 1.1674, because we round to 4 decimal places. Now let's actually put this into practice with some exponential equations that are requiring a log to be able to actually solve. One way to do these is to switch them into logarithm form. So we would have, here's your loop if you need it, log base 6 of 40 is x. And then we can use that basement and attic idea with our change of base formula. So log on top, log on bottom, and our basement number would be 6. Our attic number would be 40. And we can type into our calculator log of 40 over log 6. And we get that, whoops, forgot to make it equal x. We get that x is equal to 2.0588. Now, the second way to do this is actually the way that I prefer, because as we move into more intricate exponential equations like you see in number 7 or down in number 9, this idea of changing into logarithm form gets a little confusing when both sides have an exponent. So this way, I can just solve it one way. I don't have to remember which one to use as the base, which one to use as the exponent. I can do it the same way no matter what kind of equation it is. So what we're going to do is we are going to do what's called taking the log of both sides. And that just really entails writing the word log in front of both sides of the equation. And simplifying. So we have an x that we can use our power property for and move it to the front. And then to get x by itself, I would divide both sides by log of 6, because log of 6 is really a number. So to separate it from our coefficient of x, we would divide both sides. So x is equal to, and remember we just typed that into our calculator, 2.0588. And we don't need to check for extraneous solutions in this case because we started with an exponential equation. And you'll recall that exponential equations have a domain of all real numbers, which means x can be absolutely anything. So we don't have to check for our extraneous solutions. Now, if you choose to do it this way, that's not a problem. Just make sure you show all steps. But I would recommend using this way for all of them so that you don't have to make decisions as to when it's easier and when it's not. But it's completely up to you. This is how I'll be working out the rest of the problems. So I will take the log of both sides here. Log of 2.1 to the a plus 2 equals log of 8.25. I'm still using a base of 10 here so that I can use my calculator to actually calculate the logs. Powering property says that we have to move that a plus 2 to the front. Log of 2.1. And then the right side of the equation will just be log of 8.25. So this log of 2.1 is my coefficient here. So we are going to need to divide both sides by log of 2.1 in order to get the parentheses by itself. So we'll type into our calculator log 8.25, close your parentheses, divided by log 2.1. And we have that a plus 2 is equal to 2.8442. Now, I am trying to get this 2 to the other side so that a can be alone. So I need to subtract it from both sides. So in our calculator, we can just subtract 2. We could have done that in our head too, but I want to demonstrate that our calculator really can do the heavy lifting, especially if you are uncomfortable with large decimals or numbers with a lot of decimal places. I suppose 2.844 isn't really large. Number 6, we're going to attack the same way. We're going to take the log of both sides. Log of 7 to the x squared equals log of 20.42. That x squared becomes the coefficient of the log. And I like to put it in parentheses to remind me that I'm leaving it exactly where it is. Then I need to divide both sides by log of 7. So I have x squared equals log of 20.42, close your parentheses, divided by log of 7, 1.5502. Now to get this x by itself, we're going to have to square root both sides. And you may recall that we need to put a plus or minus in front whenever we square root both sides. Square root of second answer, that's the second and the negative button to get the A and S there. And I get 1.2451. Make sure that you are never using the rounded number to actually make calculations. Let your calculator put the entire decimal so we get a more accurate answer. If we round at each step, then it's kind of like the game of telephone. It gets more and more warped the further that we move along. Now, one of the skills that we need to be able to do is to solve an exponential equation that requires logarithms and does not require any sort of distribution. That's kind of what we've been doing with these 3 problems. But number 7, we have to be careful. This problem could actually go for either skill depending on how you set it up. And I'll show you what I mean in just a second. We're going to take the log of both sides first. So log of 11 to the b minus 3 equals log of 5 to the b. And our exponent is going to move to the front on both sides this time. So I have b minus 3 times log of 11 equals b times log of 5. So here's where I was talking about it could go either way. It could be representative of both skills. If I were to divide both sides by log of 5, then I would have my long nasty decimal right here, and I would need to distribute to both the b and to the 3, which sounds pretty awful, and I really want to avoid that at all costs. So instead, though, if I took and divide it by log of 11 on both sides, I move the long nasty decimal to the side that I don't have to distribute. It just has a b behind it. Now there will be some, like in number 9, where distribution is unavoidable, but if you can avoid it, I suggest that you do. So all that's left on the left-hand side here is b minus 3, and we'll need to type into our calculator log of 5 divided by log of 11. 0.6712, and there's a b behind it. Here's where a lot of students really get confused. We are trying to get b's by themselves, and that means that we need to move them to the same side. So I need to move this b to the other side. A lot of students really struggle with being able to see that because of this long decimal here. So if that's you, I suggest maybe changing it into a problem that makes a little bit more sense, maybe a simpler problem to decide what to do next. If this was b minus 3 equals 2b, it would be clear to us that we would need to subtract 1b from both sides. So that's what we're going to do now. We're just going to use a decimal instead of 2. So minus 1b minus 1b. That cancels this out and leaves me with negative 3. And I have this long, nasty decimal already typed in my calculator, so I'll subtract 1 from it, and I get negative 0.3288b here. Remember, the b's do not cancel out. If this was 2b minus 1b, it would be 1b. So don't cancel out the b's just because it's a decimal. Then I would need to divide both sides. Again, you can kind of make it into an easier problem to decide what you would need to do. If this was negative 3 equals 8b, you would know you had to divide by 8 on both sides. So we're just going to divide by the decimal on both sides. We don't change our process just because the decimal is there. So negative 3 divided by that long nasty decimal, second answer. And so I got b equal to 9.1237. Number 8, we'll take the log of both sides. Log of 5 to the 4n equals log of 33. That 4n we know goes to be the front. And we'll put it in parentheses. Now I need to get that 4n by itself, so I'm going to divide both sides by log of 5. So we have log of 33 divided by log of 5. 4n equals 2.1725. Now we need to divide both sides by 4. N equals 0.5431. Number 9. Now I can tell off the bat that I'm going to need to use distribution because if we look at our exponents, both of these exponents have an addition sign. It's got a number added or subtracted to my variable. So if that's the case, you have no way to avoid it like we did in number 7. If we looked at number 7 again, only one of my exponents had a number added or subtracted to the variable, so I was able to avoid it. But that's okay, that's one of the skills that we have to learn. So we'll take the log of both sides. Log of 6p minus 1 equals log of 4 to the p plus 2. We need to move that exponent to the front. Parentheses, p minus 1, log of 6 equals parentheses, p plus 2, log of 4. So no matter what number I divide by, I'm still going to have to distribute a long, nasty decimal across. So I choose to have to distribute across a 1 and a negative 1 over having to distribute it to a 1 and a 2. But honestly, it doesn't really matter. It's not that much more challenging to multiply it by 2. So we have log of 4 that we're going to move. You want to move the logs to the side that you want your decimal to end on. So log of 6 divided by log 4 gives me 1.2925 times p minus 1 equals p plus 2. It's time to distribute. There's no way around it. So we're going to distribute it to both. Multiplying by 1 doesn't change anything. 1p 1.2925 times negative 1p is negative 1.2925, and it equals p plus 2. It's time to get the variables on the same side. So I have 1p over here. I'm going to subtract it from both sides so that I can get all the p's onto the left. So here I'll subtract 1, or you can do that without your calculator as well. Now here we can't use second answer. We are going to have to add our 1.2925 to both sides. Don't get ahead of myself here. Okay, for this side, when we add 2, unfortunately our options are a little different than what we've done in the past. In the past, we've been able to use this answer here, but if I did 2 plus and I tried to do answer, it'd be pulling this number instead of this number, which is what I want. So instead, it's going to depend on your calculator, but you have really 3 different options to use. You can do 2 plus, and if your calculator allows you to, you can scroll up and hit this one, and there's your number. You still don't have to type anything in. And it's a perfectly valid option, even though technically it is using rounded numbers, as we'll see in a minute. And it equals 0.2925p. Second option is if your calculator doesn't allow you to go up and select the number that you want, you can do 2 plus parentheses and type in what you had before. Log of 6 divided by log of 4, and get your number as well. Now, technically speaking, these two this time gave you the same exact number, but there are instances that you'll see where this number is actually a little longer because it was using a more precise number, or it's rounded to something different at the back, just so that you're aware of that. But this works just as well if you're not able to go up and highlight. I would say highlighting, if you're able to, is the option I would choose. The third option is that you can just retype all of these numbers. You're able to see them on your screen, write them all down, or retype them in their entirety and use that for your answer. Do not just use the 4-digit one. Use the entire decimal. If you use the 4-digit one, you're going to be a little bit off. Okay, so we have this number equals 0.2925, and we need to divide by 0.2925 on both sides. So I can use division here, and we're kind of in the same boat again. You can either go up and highlight the number that you want. That's why we write so many decimal places, so we can find it, and press enter. Or you can retype it and press enter. And we get that P is equal to 11.2571. We're going to do 2 more examples. This time we're going to be using E. So in this example, we have to get our exponent, or our term with the exponent, all by itself first. So in the previous problems, they were already all by themselves. This time we've got to do a little work first. So we're going to add 24 to both sides. We get 5e to the x equals 16 plus 24, which is 40. Then we have to divide by 5 on both sides. E to the x is equal to 8. But once we are able to do that, then we can just use a natural log, switch it to logarithm form, which means I'm going to be doing log base E, or natural log, of 8 equals x. And I can type it into my calculator. So it's kind of a breath of fresh air beyond what we were just doing that had so many steps and was so challenging to follow through with all those crazy decimals. We just have one little decimal at the end. 4 decimal places. Let's do one more. We'll subtract 9 from both sides, giving us -3 e to the x equals -5. Divide by -3 on both sides, and e to the x will equal 5/3. Now I can switch it into exponential form. Just like when we had our log equations, and one of the goals that we had was to get one log all the way alone so that we could switch it to exponential form. With these, we are trying to get one exponent or power all by itself so we can switch it into logarithm form. So log base E is natural log of 5/3 equals x. So we'll type ln in our calculator. It's the button right below log, 5/3, and we get our answer.